Okay, question 1 is just a general reminder about the way the periodic table works. So do you have groups where the elements have similar properties? Well, obviously yes. Here's group 1, for example, and they're all reactive metals that form 1+ ions. The other end here you've got group 0, they're all unreactive gases. So yes, they all share similar properties, at least when they're within a group. Going across a period, which is B, then you do get repeating trends. So for example, you go from a metal and then gradually increasing ionization energy, decreasing radius, becoming less metallic, and then becoming non-metals, and then it comes back to here and repeats back to being a metal, and then repeats the same trend, increasing ionization energy, decreasing radius, becoming more non-metallic, and so on. So yes, that one is true as well. Increasing atomic number, well yeah, remember the atomic number is the number of protons, but it's the number at the top of the square for each element in your periodic table, and so you can see just by looking at it that it does indeed go in order of increasing atomic number. So the one that's wrong is the last one, because as you go down the halogen group, which is group 7 or group 17, depending how you want to number it, going down from fluorine to iodine and then the ones below, you know that what happens is that their ability to attract an extra electron, which is what these elements do when they react, their ability to attract an extra electron decreases because you're adding on more shells, got more shielding, therefore the attraction to an electron in the outer shell decreases. So they become less reactive as you go down the group. So D is the one that's wrong. Question 2 then, I think these are nice small molecules, so just go through and scribble down, or at least in your head, visualize what the shapes are. So ethene is the first one, and remember that each of those carbons has 3 areas of electron density around it, a double bond, 2 other bonded pairs, no lone pairs. So when you have 3 areas of electron density like that, that's trigonal planar, so that's 120 degrees. Water has 2 bonded pairs and 2 lone pairs around the oxygen. And remember the way it works is a tetrahedral angle is 109.5 when you have 4 bonded pairs, but each time you put a lone pair in, it decreases the angle by 2.5 degrees. So because you've put 2 lone pairs in instead of bonded pairs, it's decreased it by 5 degrees. So that's 104.5 degrees. Ammonia again is similar, because it's based on that tetrahedral arrangement, but this time with just 1 pair that's a lone pair instead of a bonded pair, so it looks like that, pyramidal shape. So 109.5 minus 1 lot of 2.5 degrees for 1 lone pair is 107.5 degrees. And then methane is the one that's truly tetrahedral, because you have 4 bonded pairs all repelling each other equally, and so you get the classic tetrahedral angle, which is 109.5 degrees. So the one that has the biggest bond angles is ethene, and so the answer is A. For number 3 then, it wants the percentage by mass of nitrogen in that compound, so that's going to be the MR of N2, because there are 2 nitrogens in there, so 2 N's, or 2N if you like, divided by the total MR times 100. So you can just plug the numbers in. You get 28 for your 2 nitrogens, and then you get 96 for the total MR of that lot, times 100 equals 29.17%, and so the answer is C. Question 4 is asking you about sustainability as measured by atom economy, and the idea, remember, is that the higher the atom economy, the smaller the fraction of the mass of materials you put in ends up being wasted, and therefore that's more sustainable, because it means that you're making better use of your raw materials and you're creating less waste that has to be disposed of. So what we're really asking for this question is which of these 4 has the highest atom economy. Now you could go through and calculate them all. So remember, atom economy is equal to the MR of the useful product, and we're going to have to assume for these, it doesn't say it in the question, but normally if it's an organic reaction you assume that it's the organic product that's the useful one. So it's the MR of the useful product divided by the sum of the MR of all the products times 100. So it's easy enough to do, it's just a bit laborious. So you could go through and you could do that for each of these, and it's worth doing that just for a bit of practice, and those are the numbers you should get. And so you can see that the one that has the highest atom economy, therefore is making the best use of materials and producing the least waste product, is this one, and so the answer is going to be D. The only issue is, though, that would have taken you quite a lot of work for the sake of 1 mark. So the question is, how could you have done it quicker? And the answer is, well, to get a high atom economy, what you want is a top line to be as big as possible and the bottom line to be as small as possible. In other words, you want a high MR for your useful product and then small MRs for whatever other products you've got. And so going through these, you can see that, these two, the middle two, have quite high MR other products. So NaHSO4, NaBr, those are quite high MR compounds. And so you're not going to expect these to have very high atom economies, because that bottom line is going to be big, because the waste compounds have big MR values. So you could straight away think, yeah, I don't think it's going to be those. That brings it down to these two. They both have water as the other product, but you can see this one is a bigger molecule than that one, so this one has a bigger MR than that does, and therefore it's going to be a bigger fraction of the total mass of the product. So therefore you could figure this one out. It's up to you, but that would actually, I think, for most people have been quicker than crunching all of the numbers. The first issue in question 5 is to remember that at any particular temperature and pressure, the volume of a gas is proportional to the number of moles, irrespective of what substance that gas actually is. So that's embodied in the idea that 1 mole of gas occupies 24 dm cubed at room temperature and pressure. So what we can say, therefore, is that this equation, which tells us that twice as many moles of NO react as O2, can also be interpreted as meaning that twice the volume of NO reacts compared to the volume of O2, because the volume is proportional to the number of moles. So we can therefore tell which one is in excess very easily, because in order for all of that O2 to react, you would have needed twice as many moles of NO, right, because of that 2 there. So you would need 12 dm cubed of NO for all the oxygen to react. And you can see you haven't got that much. So that means that oxygen is in excess, because there's insufficient NO. Okay, so that's the first thing. You've got to be clear which one is in excess. And then you think, right, okay, what that means is that all of this NO therefore reacts, right? Because it's not in excess, and if it's not in excess, it means all of it reacts. So that means that 8.0 dm cube react, and therefore from the equation, if 8 dm cubed of that react, 4.0 dm cubed of O2 react. But because we had 6 dm cubed of O2, that means we have 2.0 dm cubed of O2 left over. Right, because we had excess, and the excess is the amount that reacts, which is 4, because it's half as much as the NO, taken away from the total 6. So that leaves us with 2 dm cubed. And how much NO2 will we get? Well, the equation says however many moles of NO react you get that many moles of NO2. So whatever volume of NO reacts, you get that volume of NO2. So we get 8.0 dm cubed formed. So at the end, what do we have? Well, we have this 8 dm cubed that's formed, and we have this 2 dm cubed left over. These ones obviously have gone, so this is what we've got left at the end, and so we have a total of 10 dm cubed left at the end, and therefore your answer is B for that one. Question 6 is just the ideal gas equation. So we start with PV equals nRT, and we need to rearrange it to get V equals nRT over P. And then it's just a question of putting the numbers in, but being really careful. Remember that you've got to know what the units need to be here. So N is the number of moles, which is 0.01. R comes off your data sheet, is 8.314 joules per Kelvin per mole. T is the temperature in Kelvin. So we've got to add 273 onto our 350 degrees C, which is 623 Kelvin. And P is the pressure, but that needs to be in pascals, not kilopascals. So 200 kilopascals is 200 lots of 1,000 pascals, 200,000 pascals. So those are your numbers, and if you crunch all of those, your answer comes out as 2.59 times 10 to the minus 4. But remember, that will be in cubic meters, is the way this calculation works. But the answers you have to choose from are in cm cubed. So remember, a cubic meter is 1,000 dm cubed. So if we divide that by 1,000, sorry, multiply that by 1,000. If we multiply that by 1,000, we get 0.259 dm cubed. And if we want to put that into cm cubed, we have to multiply by 1,000 again and get 259 cm cubed is the answer, which is therefore B for that question. In question 7, the thing to do is just to write the equation for the reaction, which is kind of obvious, you almost don't have to write it, but you can see that if X is reacting with Cl2 to make XCl2, the equation is just X plus Cl2 goes to XCl2, and that of course tells you that equal moles will react because it's a 1-to-1 reaction. And so if you've got 0.01 moles of chlorine, you'll have 0.01 moles of X, which is 0.24 grams. Okay, so therefore you can get the AR of X is mass over moles, which is 0.24 over 0.01, which is 24. And so you just find the element whose AR is closest to 24, and the answer is magnesium, which is 24.3, but we've only got this number to 2 decimal places, 2 significant figures, so therefore that fits. So the answer is it's magnesium, and therefore the answer is B for that one. So question 8, we've got to find the formula of copper 1 phosphate 5, which sounds complicated, but actually this is a really easy one because it gave us the formula for phosphate 5. Copper 1, of course, just means that it's Cu1+, and therefore it's just the usual business of balancing up the charges, that you need 3 of those to balance 1 of those. So it's just Cu3 PO4, which is answer D, and it's as simple as that. So for question 9, we just got to go through and look at what happens to the oxidation states of the chlorine. So if it's Cl2, the oxidation state is 0, remember, for an unreacted element. Here hydrogen is +1, so the chlorine is -1. Here hydrogen is +1, oxygen is -2, so we've got -1 from those two, so the chlorine is +1. So you can see that in that one some of the chlorine is reduced, going from 0 to a more negative -1, but some of it is oxidized, going to a more positive +1. So that's a disproportionation, and in fact that's a reaction you should have known without having to work it out, because that's the classic reaction of chlorine and water. With this one, got 2 oxygens, takes you to -4, and so the chlorine here is +4 to make that lot balance out because it's a neutral compound. Here 2 oxygens is -4, but we've got +1 from the sodium, so -4 + 1 is -3, so the chlorine is +3 to balance that one out. 3 oxygens is -6, +1 is -5, so the chlorine is +5. So that again is a disproportionation. Some of it's oxidized from +4 to +5, some of it's reduced from +4 to +3. So neither of these is the answer. Here, again, you can see it's going to be the same thing. We will work it out, but you can kind of see almost without working it out that that's yet another disproportionation, because so we've got 3 lots of oxygen is -6, +1 from the potassium is -5, so the chlorine is +5. KClO4, 4 lots of -2 is -8, +1 for the potassium is -7, so the chlorine is +7. And here, of course, potassium is +1, so the chlorine is -1. So that again is a disproportionation, because some of it's getting more positive, being oxidized, but some of it's getting less positive and being reduced. So it's pretty much got to be the last one, but let's just check. Hydrogen's +1, so chlorine there is -1. Here it's still -1, so these chlorines haven't changed, but these ones, of course, have gone to 0, because that's the element. So that one, the only change in the chlorine is when it becomes more positive, so it's oxidized. No reduction of the chlorine, because it's the manganese that's being reduced from +4 to +2. So D was therefore the answer, is the only one where the chlorine is only oxidized. Question 10 then is just an enthalpy profile diagram. It looks a bit weird because they've left the arrowheads off there. I think they've done that deliberately just to make it a bit more confusing for you. But remember, when you draw these diagrams, you must put one-way arrows on there to indicate which direction the activation energy is, or the delta H for reaction is. So, which one of these is correct? It wants to know. First of all, is the activation energy of the forward reaction 120 kilojoules per mole? Well, the answer is no, because the activation energy for the forward reaction is that. Okay, going from your starting state to the top of the hill, so it's plus 150. So A is not correct. Second one is the activation energy of the reverse reaction plus 270. So for the reverse reaction, that would be starting with the product and going to the top of the same hill, remember. That's the key thing. When you have a reversible reaction, the top of the hill is the same. So that is the activation energy for the reverse reaction. And you can see that that's equal to 120 plus 150, which is 270. So that's correct, and therefore B is the right answer. We'll just quickly look at the other two, although of course you wouldn't have to do that because you know you've found that there. Is the enthalpy of the forward reaction minus 30 kilojoules per mole? Well, clearly not, because this is the enthalpy change for the forward reaction, so it's minus 120 kilojoules per mole. And is the reverse reaction exothermic? Well, no, because the reverse reaction is this one, so it's positive, and therefore that's endothermic. So B was the right answer.